Hello, welcome again to Virtual Space 3D. I'm Amanda Bush. Our monthly program reports on the latest exciting progress in the commercial development and scientific exploration of space. In this month's show, I begin with a report on the role of satellites in the search for the missing Malaysian airliner. Then I'll report on gravitational waves at the birth of the universe, flying weightless in a swimsuit, a new Gulley on Mars, and how you can name a crater on Mars. The disappearance of the Malaysian MH370 airliner is a horrendous tragedy for the victims on the plane and for their families and friends. What has made the nightmare profoundly distressful to those loved ones has been a long period of not knowing what happened to the plane. It has been quite a surprise to the public that an airliner could simply disappear. Most would assume that in our high-tech world, airplanes are under constant surveillance with radar and satellites. However, for long flights over the oceans, planes are often out of reach of radar, and some planes do not maintain continuous contact with communications satellites. Furthermore, Earth observation satellites do not transmit views of the usually empty surfaces of oceans. Nevertheless, space systems are making critical contributions to the search for the plane. The satellite operator Inmarsat, in particular, has provided key information on where to focus the search. One of the services that Inmarsat provides is transmission of data from airliner engines to maintenance services that monitor the condition of the engines during flight. For flight MH370, this transmission was switched off, but it did not disconnect completely. A ping was still being sent every hour to maintain the transmission connection. This ping allowed Inmarsat engineers to determine that the airliner continued to fly for several hours after it stopped all other communications. Inmarsat could not determine the exact location of the airliner, but they did find an arc along which the airliner must have been when it ceased transmissions altogether. This greatly reduced the areas that needed to be searched. Images from both government and commercial Earth observation satellites were then used to spot debris in the areas indicated by the Inmarsat data. The ships sent to look for the debris are being tracked by companies like Exact Earth, which have satellites that detect a signal emitted by ships at sea to avoid collisions and to prevent going aground near a coast. Of course, GPS navigation satellites are crucial for both planes and ships in knowing where they are and where the debris is located. This tragedy was unfortunately not prevented by high-technology satellite services. But satellites will help prevent a future disappearance if this disaster motivates a requirement that all commercial airliners maintain continual satellite contact in a manner that cannot be turned off. You no doubt have heard of the Big Bang as the initial event that created the universe. It explains why all the galaxies are speeding away from each other like dots on an expanding balloon. You may not have heard of the theories. Oh no, sorry, wrong picture. Okay, that is the right one. You may not have heard of the theories describing details of the truly momentous event. One of those theories is the inflation model, which postulates that the initial universe started out as an infinitesimal speck of terrific density and energy that soon underwent an almost instantaneous gigantic expansion of many, many orders of magnitude. The rapid inflation of that speck resulted in a universe that soon lit up in a burst of light as electrons and protons combined into neutral hydrogen atoms and became transparent to all the hot thermal radiation that had been bound up within a plasma of charged particles. That initial burst of light is still visible today as a microwave background glow around all the stuff of matter in galaxies and stars. Applying Einstein's theory of relativity to the inflation model leads to a prediction of a Ripley pattern in the distribution of that microwave glow due to gravitational waves. The BICEP 2 experiment installed a special kind of telescope in the clear skies of Antarctica to observe that microwave glow. In March, the first results from their observations were released, and they do indeed show a ripply pattern in the microwave background similar to what is predicted by the inflation model. Independent confirmations and more detailed, higher resolution observations are needed, but this could turn out to be one of the greatest discoveries in the history of cosmology. Most people who fly on zero-G's G-Force One Boeing 727 aircraft wear astronaut-style jumpsuits while they experience weightlessness during the plane's parabolic leaps up and down. However, supermodel Kate Upton recently got to frolic in microgravity in a bikini. Her photos for the annual Sports Illustrated swimsuit issue were shot on a zero-G flight. She seemed to enjoy it, and she did not experience any motion sickness problems. Her weightless ride got lots of publicity for zero-G, which will likely lead to a boost in business for the $5,000 tickets. Over 12,000 people have experienced weightlessness since the company began selling flights in 2004. Zero-G will soon have some competition in the US. The company Swiss Space Systems just announced that they plan to offer similar parabolic flights for the public on their Airbus 300 aircraft. It will fly from the shuttle landing strip at Kennedy Space Center. Last month we mentioned streaks on the sides of some mountains on Mars that appear to be caused by a salty water ice melting in the sun and creating a thin mud that flows down the cliffs. A recent image from the Mars Reconnaissance Orbiter shows a brand new ravine that formed on a mountainside since 2010 when it was last imaged. This deep ravine, however, is most likely caused by the melting of frozen carbon dioxide, or dry ice, mixed with dirt and not by water. The extremely thin atmosphere on Mars would lead to the evaporation of water before it could build up enough to cause such a deep and wide ravine. Alan Stern is a space scientist and a former top NASA official who is involved in many projects. He is, for example, the chief investigator for the New Horizons mission to Pluto. He is also leading efforts to put scientific experiments on commercial suborbital space vehicles, and he is a leader in the Golden Spike venture to put humans on the Moon with private funding. And Dr. Stern is the chief of an unusual company called Untitled, which aims to raise money to fund space science projects by offering an array of public participation activities. Their first full-scale initiative is the Mars Crater Naming Project. There are about 600,000 craters on Mars and only a few hundred have names. You can go to uwingu.com and use their interactive map to find a crater you like, at a price you like, and give it a name of your choice. These names, of course, won't be recognized by any official government agency or professional science group, but that is no big deal. The people who eventually settle on Mars can decide for themselves what names to use for craters and other features. In fact, Mars One, a private organization dedicated to sending people to settle the red planet, will put the Uwingu map on an unmanned spacecraft that it hopes to land on Mars in 2018. That ends this month's show. Join us again next month for the latest news from the frontiers of space exploration and commercial space flight. I'm Amanda Bush. Good night and ad astra.